Well, welcome back. We've made it to the dizzying heights of Module 4 so far, so we're certainly making some progress. And in this module, we are going to look at some techniques that we can use to optimize the performance of the queries that we're performing against those tables.
So I'll finally get my question answered about speeding up queries for multiple tables.
Absolutely.
All right.
All right, well, let's talk a little bit about how we can use indexes, first of all, to improve the performance of our database. So when you hear the word index, if you're not in the database world, I guess what you think of is an index in a book. So you might have a book, and in that book, when you open it up, you may have a book like a telephone directory. So things are already organized in the right order. In effect, the index is the content itself. It's already in the right order. And as you flick through the book, everything's in the appropriate order, so it's easy to find things. So you can think of that as being a kind of indexed content. It's in the right order already. And the other thing you might find is you might have an index at the back of a book that you go as a kind of secondary index, where you can go and look up specific things that are in that book. So perhaps in our telephone directory we might have different categories of things that we want to look up. So if I want to look up a restaurant, I can go to the back and find out pages for different restaurants or whatever it might be. So you can get this idea of an index as a way of organizing information so that you can find it easily. That's the point. It means I have to read through less pages to get to the data that I'm looking for, get to the information I need. So the same thing is true in a database. Here's a table in my database. I've got this sales.product table, and it's got a list of products in there. And all of that under the covers will actually be stored on pages in disk. We literally call them pages that are stored on the disk. And I want to make it easier to look these things up and reduce the number of pages I need to read to get to the record that I'm interested in. So I'm going to create something called a clustered index on this table here. So I've got this create clustered index statement, give it a name, in this case IDX product ID, and I'm creating on that table, and I'm doing it on the product ID column. So what's going to happen is the pages where that data is stored is physically going to be organized on the disk in the order of the product ID. That's the field that's part of that index. I could have multiple fields. I could make an index that spans multiple fields, a composite index if you like, but in this case it's just on that one field. So the data pages, all the records will be stored on pages in that order, in the order of product ID. And that means when I come to query that, I can go and use this index. I've got this index page here that I'm going to look up first of all, and I can see on that index page that, right, if I'm looking for anything that begins with a 1, then I'm going to take that left fork there, and that's true right the way up to 3, and then if it's 3 or above, I take the right fork. So you can imagine I get this kind of tree-like structure in the index that I can navigate the different branches of the tree to get to the page that I need. And that's going to reduce the number of pages I need to read. If the index didn't exist, I would just have to read all of the pages in the table and then go through them one by one to find the data that I want. Now the other thing I can do, I can create one clustered index per table, because of course it can only be in one order, but I can also create something called a non-clustered index, and I can create multiple non-clustered indexes, and again they get a name. So in this case I'm calling it IDX name because it's on the name column. And you can see what happens here is I've got an index that's based on the name. So I've got all of the A's take that left fork, and then from M onwards I go to the right fork. And then the page that I get to from there actually points me to the index page of the clustered index. So if I've got a clustered index and then I build a non-clustered index on top, actually what happens is the non-clustered index helps me find the appropriate pages in the clustered index to then get to the records I need. So there's a level of indirection. If I don't have a clustered index, then I get a row ID and I go and search for the individual row in the heap of pages that we have without the clustered index. So you can see the idea then that I create a clustered index that determines the order that the data is actually stored in on the disk. I can have one clustered index per table, and then I can create one or more non-clustered indexes for additional fields that I commonly search on, just to reduce the number of pages I need to read to go and get that data. So just to remind you then, a clustered index determines the order in which the rows are stored. You can only have one per table. If you don't have a clustered index, then the table, by the way, is known as a heap. And a non-clustered index stores pointers either to the row ID of a heap if you haven't got a clustered index, or to the cluster key of the clustered index. And you can have multiple non-clustered indexes on a table.